Hello students of Phys40b, I am Scott Medjian, and today I will be doing week 1's discussion section 8 problem number 22. Two meteoroids are heading for Earth. Their speeds as they cross the moon's orbit are 2.0 kilometers per second. Note here we only need to do part B. So part B is the second misses the Earth by 5,000 kilometers. What is its speed at the closest point? As we should with all physics problems, let's start by drawing a little diagram. Here's the Earth, and here is the orbit of our moon. Now let's go ahead and draw our little asteroid. And remember, he misses the Earth by 5,000 kilometers. And remember, his initial speed, VI, is 2.0 kilometers per second. Now let's go ahead and write both of these in terms of meters so we don't forget to convert our units later. So remember 2,000 kilometers or 2,000 meters per second, and I'm going to write this one in scientific notation, 5 times 10 to the 6th meters. So now we have to think about how to do the problem itself. So the way I thought about it was in terms of energy. So let's have Ki plus Ui, kinetic plus potential, initial, plus or equals Kf plus Uf, or potential F. Remember, kinetic energy is just 1/2 mv squared, and potential, if from physics 40a, was mgh. Now, tricky part, we have to use a different formula that was in chapter 13 of our reading. It is negative big G, big M, little m over r. So remember, we're going to be using this equation, not the one from physics 40a. So let's go ahead and plug these in. So we're using 1/2 mv squared, and this is minus big G, big M, little m over r. This r is the distance between the center of the Earth and the asteroid. Now, the distance between the center of the Earth and the Earth's surface is just the radius of the Earth, or RE. The distance between the surface of the Earth and the asteroid, we're going to write that as RM. But that value I found on the internet as this value from NASA. And for all the other values I found in the book. But I just wanted to make that one clear that it is not in the book. You do have to find that one on your own for RM, the distance to the surface, from the surface of the Earth to the moon's orbit. So anyway, resuming with the problem, we're now writing the equation for kinetic energy final, and also the equation for potential energy final. Remember, this big M is going to be the mass of the Earth, and the little m is going to be the mass of the asteroid. The big G is just the gravitational constant. For this little r, this is going to be the distance between the center of the Earth and its surface, and that final position of the asteroid as it's passing the Earth, getting within 5,000 kilometers. So that is just RE plus that 5,000 kilometers, or 5 times 10 to the 6th meters. So now all we need to do is solve the equation in terms of the F, which I've done before, and I will write that out for you. It's VI squared plus 2GM minus 1 over RE plus RM plus 1 over RE plus 5 times 10 to the 6th. And if you solve that, plug in all those values, you get 8,940 meters per second. And that is the solution.